Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to continue with the nice characteristics of the dummy variables and how we can take advantage of them. So we're going to switch in STATA to make this process a little bit easier. In the previous video, we used the NLSW88 dataset of STATA and saw the variable union, which was a dummy variable, and learned that the mean is in fact the proportion of the people who said yes, or the people in the group yes. So now we're going to show that the dummy coefficient equals the difference in means of y between the two groups. For this thing, we're going to do, again, a tab, but on another variable, which is wage in here. And since we are still interested in the union variable, we're going to do that by union. The summary statistics, in a sense, table that is going to be shown in here is going to give us the mean of wages for the non-union group and the mean of the wages for the union group. And as you can see, for the non-union group, it's 7.2. For the union group, it's 8.67. And if we take into consideration the proportions for the non-union and union, then we can also calculate the total for the wages for the entire data set as 7.56 in here. Okay. So keep in mind, when this mean in here was calculated, it was only the lines, the observations where union is equal to 0 that were taken into consideration. Now, what if we run a regression of wage on union? What are we going to see? Like, how does that information that we just saw in here translate? When we run this simple regression, we're going to see that the coefficient for union here is 1.46, and the constant, look at the constant, is 0.20466. So that is the same identical number that we saw in the tabulation table here for the non-union group. In one of our previous videos where we went through the cases one by one, we said that the beta 0 by itself should be the intercept for the lines where the dummy was equal to 0. So the constant here, the intercept, it's exactly the same as the mean for the case where union is equal to 0. So it shouldn't really be a surprise that we found the mean for non-union being equal to the constant in here. The other thing is the coefficient in here for union. We learned in the previous video that it should be our beta 0 plus beta 1, which in this case is the beta of union. In fact, if you calculate 7.2 plus 1.46, you're going to get, and if you do approximate correctly the numbers, you're going to get this union mean that we got here of 8.67, okay? So intercept in here, 7.2, and then 1 plus 1.4, we're going to get the 8.6 that you had in here. So they match. Running a regression with only a dummy variable, it's exactly the same as computing the difference in group averages. And this we also saw with the case scenarios. So if in a regression you're only including the dummy and you're not including any of the other x variables, the regression is just a structured way of comparing the means for that particular variable, in our case wage, between the two groups in here. Okay, so it's just a structured comparison of means. In other words, dummy variables shift the intercept, which is exactly what we saw in the graphs as well in the previous video. I hope that this helped give you a more structural view on what happens with the numbers and not just graphically when you include a dummy variable. And I hope you have fun working with them on STATA. Stay tuned for more videos.